And this video is a quick factoring review because you're going to need to be doing quite a bit of factoring in the rationals unit. And the faster that you are and the more confident you are in factoring, the better off you'll feel in this unit. So I'm going to start off with a general factoring problem that you're going to need sort of all the steps to solve, just to go through those steps. So the first thing we do is we check for a GCF, see if there are any factors that are common to each of the terms. And there's no common factors here, so I'm just going to move straight on. Then the second thing I do is I multiply my a term, my quadratic term, and my constant term. And so that gives me here negative 300. And I like to carry the a squared with it just so that I know I don't lose track of the variables. So now I'm looking for two factors of 300 that also add up, two factors of negative 300 that adds up to positive 44a. So here's how I do this. I know that one needs to be negative and one needs to be positive because they need to multiply together to give me 300, which means I'm looking for the difference between two numbers. So I'm going to figure out what the factors are of 300 and then group them until I can find a grouping that works. So negative 300 I think of as negative 3 times 10 times 10. And I'm going to just sort of leave this negative sign off to the side for a moment. And I'm going to think of each of these 10s as 2 times 5, which means that the factors I have to play around with are 2 times 2 times 3 times 5 times 5. So now I'm just going to try grouping them in different ways and seeing if I make one negative and one positive, if I can get them to add up to this positive 44. So what if I group these three factors? So 2 times 2 times 3, that's 12. And then these two, that's 25. Well, the difference between 12 and 25 is not as much as 44. So that pair is not going to work. So what if I try, I don't know, grouping one more? So if I do like 2 times 2 times 3, that's 12. 12 times 5, that's 60. And then I've got 5 left over. Well, that gets me to 55, a difference of 55, which is closer, but now I've gone a little too far. So I'm going to maybe try a different combination of factors. Maybe I'll just try like these let's see, maybe I'll try like 2 times 3, that's 6 times, and then maybe I'll try, so maybe I'll do this 2 and 3 together, so that would be 6, and then I'll do the rest of the factors, 2 times 5 times 5, so that's 50. So 50 and 6, that has a difference of 44. So if I make this a positive 50a and a negative 6a, that will get me to where I need to go. So now I'm going to just split the center term along those lines. So I've got 5a squared plus 50a minus 6a minus 60. And so I'm going to write those in two groups, 5a squared plus 50a plus, I'm going to group these, negative 6a minus 60. And I'm just going to take the GCF from each pair. So here the GCF is 5a, leaving me with a plus 10. And here the GCF is negative 6, leaving me with a plus 10. And then I'm going to identify that binomial that was factored over it as a plus 10. I'm going to factor that out, and I'm left with 5a minus 6. And so those are my factors. Okay, so that's my solution. Let's take a look at one where we can find a shortcut example. So the first thing, again, I always do is check for the GCF, which here is x. So I can factor out that x. So it's x squared minus 7x minus 18. And now my shortcut here is that a is equal to 1. So I don't actually need to do all the grouping. And I would hope that you will avoid grouping when a is 1 if you can, because it will save a lot of time. So here I'm literally just looking at this negative 18, because 1 times negative 18, the negative 18 stays the same, and then I'm just looking for the two factors that sum up to the negative 7, so it's negative 9 and positive 2 that would give me the negative 7. And here, because this leading coefficient is 1, both of the binomials have to be x times x. They have to start with x. So then these are just my constants for the binomial. So x minus 9 and x plus 2. So that will save you a significant amount of time if you learn to identify when a is 1. Another thing that will save you a significant amount of time if you learn to recognize these difference of squares. So here you've got a square number and here you've got a square number, and they are subtracted from each other. And so the pattern for those, because the linear terms cancel out, is that one is a positive and one is a negative, and they've got the same numbers. So it's really just the square root of the first, which is 3x, plus the square root of the second, multiplied by the square root of the first minus the square root of the second. So learning to recognize those patterns will save you a significant amount of time. Here it looks almost like a difference of squares, but 12 isn't a perfect square and 27 isn't a perfect square. But don't forget about that GCF. So here the GCF is 3, and once I do that, I get 4x squared minus 9. So now I've got a perfect square and a perfect square. So I can do 2x plus 3 and 2x minus 3, and that's all multiplied by the 3 on the outside. The other thing that you should be able to recognize are perfect square trinomials. So these, of course, you could do in the first method and go through all of the steps in order to group them, right? Multiply your a times c. But it's probably easier if you can identify that you've got a square and a square, so your quadratic term and your constant term are squares, and the linear term is a double of these two factors, these two roots multiplied together. So for example, here the root of 25 is 5, root of 16 is 4, 5 times 4 is 20, 20 doubled is 40. So if you've got that, you just take the sign from the linear term, and that's the sign for both of your binomial pairs. And then you take the root of the first and the last term, so it's 5x minus 4 and 5x minus 4. And so if you multiplied those back together again, you get negative 20x and negative 20x, which doubles to negative 40x, so that's your linear term. Here you've got, again, a square, right? A square. And the root here is 3, the root here is 2. 2 times 3 is 6. 6 doubled is 12. So this will follow the same pattern. Use a sign from the middle. And so that's just 3n plus 2 and 3n plus 2. Okay. So again, the more that you do these, the more that you'll recognize them, and the more that you can identify these shortcuts, the more confident you'll be and the more time you'll have to spend on ones where you're not quite sure what to do. Okay, I hope that this review helps. There's also a practice sheet posted alongside it. Thanks.